Okay, everybody, I'm recording now. Thanks, everybody, for joining again. Hopefully, everybody had a chance to look at the email that I sent out, and in particular, looked at Luisa's video just to really get everybody on the same page in terms of color, and color magnitude diagrams. And that's really the basis of everything that we're going to be doing. So I didn't want to go on to anything else until I was sure everybody was sort of had a solid sense of that, and then sort of how that applies to our project. I sent out some of the other things to read, and Matt really jumped on it. So he sent out some good questions. But before going to Matt's questions, which were a little bit ahead of where we are, I just want to see if people had a chance to watch the video, and also if, what kind of questions you may have about just the general concepts of black body curves, color diagrams, and color magnitude diagrams.
It took me a solid 10 minutes to realize that CCD wasn't going to be talking about detectors.
Oh, yes, there's welcome to the wonderful world of shortened acronyms that are multiple.
And I'm still wrapping my head around log shapes. I got that the difference where in the infrared that we're going to be looking at should be 0 for a perfect black body, but I know that I'm going to have trouble teaching it to my students, and I know that it's something that I don't have a ton of experience with right now. But other than that, I'm lukewarm on this stuff.
Okay, fair enough. Yeah, it's basically, that's the critical thing, is that if you are like a black body, then when you take the magnitude difference, which is basically a ratio, that means when you're behaving exactly like a black body at two different filters, you will have a magnitude difference of 0 or a ratio of 1. But yeah, in magnitude space, that's a color of 0. And when we have an excess, then we have a positive difference, therefore meaning that the longer wavelength has excess flux, which gives us that positive value. And that's what we're looking for, ultimately what we're looking for.
Yeah, I need to watch it again and take notes.
Yeah, I think that's one of the reasons that Luisa did make the video. It's just to make it possible for everybody to go back and at their own pace look at it. And I will say, again, I think, she does a fairly good job of going through the whole thing, but after a certain point, for me, it's not necessarily for that video, but in other videos, I tend to actually, for the second or third time, I tend to speed it up on YouTube, and you can do that, and it's actually worthwhile because then you can actually, once you're getting more used to it, you don't want to sort of have all the connecting tissue isn't as important, and you want to get to the main point. So if you want to watch it again, and you can certainly watch it at its regular pace, but there is a way to speed up on YouTube a little bit, or a lot, and I don't think a lot works.
Yeah, I watched it on 1.25, and that was pretty good for me. I did have to rewatch a couple slides like 3 or 4 times, but it started making sense then.
Okay. Any other questions? Yeah, I often, in terms of, what David mentions about CCD color diagrams, I often just do, to avoid the CCD and charged coupled device confusion for the detector, I often just write color dash color. It's not as short as just 3 letters, but it breaks up a little bit easier, with color mag versus color diagrams. We're going to be using both of those. But okay, if there are no other questions, just on that front, Matt, would you be willing to go through your questions?
Sure. Let's see here. Let me bring it up if I can remember what I asked. All right. Well, the first one, that was something that I was thinking about when we were all together is, since this is the third revision of a similar research effort,
Mhm.
that I was just, and I think maybe part of it's just from not understanding maybe all the criteria that will apply. But my question was, it was my understanding that we're going to try to do a better job in not just applying the signal to noise ratio minimum of 10, but some other criteria, and do a better job of kind of whittling down the data set. And I guess I was wondering, what do we expect to pretty much get the same final data set, just get there more efficiently, or would we expect something different?
Well, that's part of it. So the very first version that we did, we took a very high signal to noise, a signal to noise of 10 for all the channels we were looking at. And we looked at IRAC channels 1 and 2 and compared that to IRAC channel 4 to MIPS channel 1. So we're comparing 3.5 to 4.5 microns on the x-axis. And then the y-axis was 8 microns to 24 microns. And I think, and what we learned from that was basically that we had a decent shot of getting real infrared access sources, some very unusual ones as well, that were real. So then that encouraged me to drop the signal to noise to 5 and then look at more targets. And I think what I saw in that iteration was, well, clearly I knew we were going to be getting more targets, but the quality at signal to noise of 5 was not as good as I had hoped. So in our visual checking, we had a very high attrition rate of about 50% of the sources. We were unsure of if they were good quality sources. Not that they weren't real necessarily, but the quality wasn't good in some image form, and we can get into the details of this later. But so part of it now is to bring in things other than simply the signal to noise calculation that they have done and as part of the catalog, part of the SEIP catalog, but to add other things, because each source oftentimes has what's called a flag associated with it, which says it's called a quality flag, how good of a quality this is. Usually that's for, more often than not, for how, higher precision and so on. So I was not as concerned with those flags to begin with, but it looks like, they may have, a lot of the sources had a lot more. This wasn't a slightly, being slightly off, that they were maybe way off in their measurement, and I'm hoping that that's captured in the flags that we're giving to the sources that we eliminated by eye. So that reduces the number of source. It makes things more efficient. So that's the part that makes it more efficient. But the part that I would like to have, and this is not a foregone conclusion, is I would like us to at least make an effort to produce a final catalog. Now, the final catalog, if you remember, just doing the signal to noise of 5 and so on, was already 400,000 sources. That's not a reasonable thing, I think, for our group or any group to do. But the main thing that I want is for us to slice the data in such a way that it gives us a useful final data set that we can publish as a catalog. And to have that catalog, we need to, not only have a pretty efficient way of rooting out bad sources, but also it can't be, several 100,000. So we have to sort of do a separate cut, which isn't about a quality of the data, it's about what the data is, what are we looking at specifically. And one of the things that I mentioned at the AAS was, perhaps we just choose all the sources that WISE didn't detect at its long wavelength channels. So in this case, what would happen was, so we could very cleanly say these are all the sources that WISE didn't look at. It's randomly distributed across the sky because it's a combination of these various surveys that people did on the sky as well as these serendipitous sources that people did with all these various different individual pointings across the sky with these big wide fields of view. I think that's one way of approaching it. Another one is sort of what's the most useful stuff. WISE itself is actually what's called rather confused in the galactic plane because WISE has a much larger beam on the sky, which means it has lower resolution when it's imaging the galactic plane, and the galactic plane is pretty crowded. So we can just say, okay, let's leave everything else out. So this isn't quite a serendipitous survey kind of deal, but we will look at the galactic plane and try and find sources that WISE didn't see, or certainly were too confused for WISE, or in some fashion, basically again bringing something that we sort of avoid the general criticism, which I don't think it's an apt one, but it's certainly there. Is that well, WISE did this, why are you doing this as well? So in many ways we avoid that by saying, look, WISE did this is specifically the thing that WISE didn't do. Those are like two different approaches. There's another one which is just the completist approach. Like, no. We're going to go for all of them. We won't go for an entire, full-on catalog, but we'll do all the 24 micron excess sources that Spitzer detected. We'll generate an automated catalog of all the sources, and then for the most interesting ones, which are these more extreme sources, those are the ones that we vet by eye. Those are the ones that we go after and say, okay, here's the catalog of really unusual infrared excess sources, culled from all of the infrared excess sources that Spitzer saw in both its surveys and pointed observations. So that's a decision that I haven't made, and specifically, but it's something that I think all of us can sort of contribute to in terms of the decision-making process. And while we're doing our efforts to write the proposal, as all of us hopefully will be able to download TopCat and start working with it, and we can do various cuts to see which approach sort of satisfies us better. So I don't know if anybody has any comments or suggestions or questions about this approach. I mean, part of it being, yes, it's going to be higher efficiency, but then where are we going to apply that higher efficiency to in terms of what the ultimate goal is? What's the final output of this project?
Yeah, I think I guess the part that I had missed is the generation of the catalog, and that that there's that in itself. I mean, we want to come up with. I kept thinking of that step between the huge number and a smaller number, and then the visual inspection. The smaller number, I mean, we'll have a very kind of hopefully well-defined set of criteria that can be used to build a catalog, and that catalog could be made available. And then with the time we have to do visual inspection, we can look at some more interesting targets. So kind of, I guess I didn't understand kind of the two parts to it there.
Yeah. Then your question was right on then, because I mean that's sort of the way I'm envisioning it. Yeah, there's definitely two parts to it. One is how do we make this efficient, but at the same time, then what do we apply that efficiency to in terms of what's the ultimate output of what we want from at the end. It's what I would like is a catalog that we can put out there of sources that people weren't aware of, that they were infrared excess sources. So when you go look at a catalog and somebody looks at that source, some other catalog, not necessarily ours, but something like Simbad, which is a compilation of all these catalogs, they can go to that source and they will see, oh, look, there's an infrared excess reported on this source, and that would come from our paper that we wrote about all the infrared excess sources detected by Spitzer.
Okay.
Is that clear for everybody? Please, don't shy away from jumping in or interrupting me.
Basically, I mean, the goal is to be able to make a bunch of flags, or to put another flag onto Simbad. I had students at that this weekend, and I hadn't, I guess, put the two pieces together. So that's a really helpful call out. Thank you.
Okay, if there aren't any other questions on that, do you want to go ahead more with the other questions, Matt?
Okay, I guess so. I don't want to dominate, but what the heck? So the other question was related to, I remember from maybe it might have actually been on both of the posters, but once you've identified your sources, then there was a plot there looking at brightness, and they kind of had the bimodal plot, and just based on brightness, the division between what sources might be in the galaxy and what might be outside of the galaxy. And I guess I was wondering, are there other things, and maybe it's just with those interesting sources that we look at, are there other ways to distinguish what those sources, where they are, how far away they are, and what they might be?
Yeah, so we didn't quite get to taking that further step with the other two projects, partly because we were less efficient in winnowing down our sources when we were doing the visual inspection, so that was the most time-consuming step. So if we reduce that step, then we can push further with this, color, with the brightness distribution. That is, if objects are closer, they're going to be brighter. If objects are fainter, they're going to be further away. On average, again, this is not an absolute statement. So then how to identify them better is, there are several ways of doing that, and that also goes into feeding back to the earlier question. Because one way of really identifying sources is to see if they've been imaged in other wavelengths. Particularly, the higher resolution ones tend to be from the ground in the optical. So if, there's all sky surveys in the optical, if we can look at an image of each of the either the extremely unusual sources or the just whatever subset that we decide that we're looking at, all the ones that WISE didn't see, for example, then we can say, oh, look, this one's sort of extended and fuzzy, most likely that's a galaxy. So it gives us a better description, so we're more sure that, oh, this was a faint source and it's extended, so it's more likely going to be a galaxy, versus it's a point source, so the image, when we look at it at another wavelength, at every wavelength, it's a little dot. Okay, that's most likely a star, so it's a galactic source.
Data do we use for that?
That one, actually, Simbad has access to all these different catalogs. The optical catalog is called the Digitized Sky Survey, which is a survey of the sky done with actually photographic plates. The first one was done in the 1950s. The second one was done in the 1990s. And then if it so happens to be in several parts of the northern sky, there are huge surveys done by the Sloan Digital Sky Survey. So they have much better imaging than the photographic plate. So if it just so happens to be there, then it's an identification. We can either just look at the image, and if by any chance Sloan had also taken a spectrum of that source, then so much the better. We can actually see what the spectrum is and say, that's the gold standard. If you have a spectrum, you can tell what it is. So that's the main thing, is that if it just Sloan didn't cover the entire northern sky, and of course we're covering Spitzer pointed all over the sky, including the southern sky. Sloan doesn't cover the southern sky, but if we're lucky enough, it'll be in one of the Sloan images, and that's a much better quality image, versus some much lower probability, but they may have had categorizations of whether it's a galaxy or a star based on a spectrum, but then we can add to that information. It's like, look, this is a star, but it has an infrared excess that Sloan would not have detected because it was only doing it in the optical. Now, there is an additional aspect of this, in that if we want to have the option of looking at things at other wavelengths to get a better sense of what these objects are, it's not a guarantee, like I said, that they'd be there, or it's really easy, because a very far away galaxy is going to look like a dot. A star looks like a dot, so a faint star looks like a galaxy, if the galaxy is far enough away. But if we want to have this option available to us, and everybody's sort of keen on following this as in terms of having a better, not just simply saying, oh, here are some sources, this group is likely galactic, this group is likely extragalactic, you want to say more about it, then that actually eliminates most of the galactic plane for us, because in the optical, where the best images are, most of the galactic plane is just this big dust cloud and we can't see anything. So even though we're picking these objects in the infrared, which penetrates the dust, that's great, but it became, if a principal goal of ours is to identify the sources based on other wavelengths, UV optical are all out in the galactic plane. So that's something that we can sort of fold into this, again, based on what we want our final catalog to be. And if we're not, doing the galactic plane, that certainly, sets up what our project is going to be in a different way than if we were going to include the galactic plane. Is that clear for everybody?
Yeah.
Uh-huh.
Yep.
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 Okay, great. Yeah. So again, none of these is the right answer. It's just how we wish to proceed. What if particular things you may want to have. For example, another aspect of, if we want to use other wavelengths, isn't just simply if we want the catalog to have maximum use for others. Well, one of the things that other people do will be doing what are called basically SED fits. That is, we're fitting the spectral energy distribution to really calculate how much of an infrared excess there is and how much dust that likely corresponds to. If we want that option to be available for most, if not all, of our sources, or if we're enforcing that requirement that we see these objects, then to make a spectral energy distribution, you really need more photometric points than just the 3 Spitzer points we're going to be using, which means, again, you have to avoid the galactic plane, because then you suddenly lose all this optical data that may be available for those sources. So that's just something to keep in mind in terms of, in the next couple of weeks as we're trying to put together how we're going to approach this. Sort of our final data set can have a lot of different kinds of uses, and what principal use we want it to be put to define sort of how we're going to approach the project. Or essentially, which infrared excess sources do we care more about than other infrared excess sources? Any other questions on this before we move on to the next question I think that Matt had? But let's go ahead.
Can I jump in with a question? Yeah. I think so. My gut says we should rule out the galactic plane because I think it gives us a more robust analysis set. But I also wonder if, I guess I don't know the actual two-dimensional, RA and DEC spatial distribution of these sources, and I wonder what percentage of the IR excess sources, or just even the IR sources in general, that would be throwing out. I guess I'd maybe need to do more digging onto the size of the distribution of the Spitzer data. Do you have a gut about that?
That's something that I'll have to look up. It was part of what, we downloaded the SAIP and we selected it. And the vast majority of the infrared excess sources will be in the galactic plane, or at least a huge percentage. I shouldn't say majority, but a gigantic plurality, if not majority, or majority, if not plurality, will be in the galactic plane. So that is... I can get that from the previous efforts that we did. So most of the sources tend to be in the galactic plane, partly, and this is the part that, again, it's just to get things a little bit muddier, is that the infrared excess can be mimicked by sufficient amount of dust enshrouding, because the dust tends to reduce the flux that you're getting at 3.5 and 4 microns, 3.5 and 4.5 microns, more than it reduces the flux at 24 microns. So in the galactic plane, you will have there will be many sources that will have an infrared excess, but oftentimes that infrared excess is not coming from an actual excess amount of infrared light from the original source, but because of the artificial foreground reduction of the shorter wavelengths. Now, this isn't as bad as for the optical. 3.5 and 4.5 microns are very dust penetrating. They're just not as dust penetrating as 24.
So how can you adjust for that? Do you have to know how far away they are to come up with some kind of correction, or there's just no way to?
Yeah, that's the thing, is that you really need to know what's called what's called the extinction. That is, how much light is being taken out, and you need to have a sense of how much dust there is between you and the source. So you need to know where the source is, and then you need to have a sense of how much dust there is. And you can do this with multi-wavelength imaging. That is, you sort of look at by looking at the colors, and for example, assuming that the source is a black body, that's one way of saying, oh, if this was a black body, how much dust would there be? And if it's sort of a reasonable number, more likely than not, then it's the dust doing the artificial excess kind of thing. But it gets into a gray area, because for a whole bunch of sources, when we're looking at the infrared, the dust is not going to matter very much, or certainly is not going to create a significant infrared excess that will get us all excited about sources that really don't have infrared excess. It's just that there will be this zone of this amount of sources that will have just the right amount of dust in front of them to make it look like they have really interesting infrared excess. But then, once we look at them and go, oh, look, they're in the galactic plane, so they will more or less be this question mark group. It's like, is this a real infrared excess, or is this an artificially, foreground generated infrared excess based on the dust between us and the source? I don't know right off the top of my head, because we never quite got to this level with the previous teams, and we only did the galactic plane last time, not the previous time. And so, but yeah, it does create less certainty about this. Completely separate from that, I had mentioned, and I would say that for this coming week, I would encourage everybody to read the other texts that I had sent, particularly the last proposal that I sent, was that there is this mission called Gaia, that is doing astrometry. It's just measuring the positions of all of these stars, huge numbers of stars, more than ever before. And so based on Gaia's result, which I think they're going to be releasing sometime this year, I got to check on that. So we can know the distances to these stars. So the advantage of having all Gaia sources that have an infrared excess is that we can know the luminosity of the excess. Remember, brightness is what you see, luminosity is the inherent amount of light that's being given off. And so by knowing how far away the source is, then this really feeds into the modeling of the sources, and such that you can get a lot more information about the dust rather than sort of vaguely guessing how much dust there is around it. By knowing the actual luminosity, it gives you a lot more constraints on how much dust there is around this particular object. Now, again, this only works for galactic objects, not extragalactic ones. Galaxies are far away. We don't get trigonometric parallax to them. But this basically is, Gaia is doing trigonometric parallax. Unfortunately, it's doing it entirely pretty much in the optical, which means the galactic plane is entirely not surveyed by Gaia. Or at least very small amounts of data can be gotten about the galactic plane for any sources that are more or less in front of the dust rather than behind the dust. So if we want to have that restriction on there, saying, hey, let's see what are all the sources that Gaia will give us actual distances to, and let's have two cuts. All the sources that WISE didn't look at, and all the sources that Gaia does look at that can give us, maybe have that intersection be, again, most of those obviously will be galactic sources, because when you're putting in what's the distance to them. All the distances to quasars and ultraluminous infrared galaxies and everything are known basically based on their redshift, but we wouldn't have the redshift for those sources, most of those sources to begin with. So this would be, we'd switch it more to be a galactic project, which I'm perfectly fine with, by the way. But then, that gives us another angle to come in at and say, once the Gaia data is released, and like I said, I think it's this year, but I'm not absolutely certain. We know there's Gaia year 1. So after the first year, they gave out numbers. We can even just use that. I mean, the uncertainties are a lot larger and they don't have as big a catalog. But I think the year 3 one is going to be coming up soon. And that one will have much fainter sources, which means much further stars, as well as, just a much larger number, which have much better distances to them. And so that way we can say, hey, look, this is all the sources that Gaia saw and so on. On the other hand, again, just to be playing devil's advocate, we could, again, do all the sources that we can do and then, leave it to other people to go back and see whether these are Gaia sources or not. Was that pretty straightforward, or was that muddying the waters too much?
Nick, I see you had the same look that I did. The like, yeah, that was straightforward, but also like adds way more complication than I thought would be possible right now.
No, and believe me, if people people wanting to go to simpler route is perfectly fine. I'm happy to do simple. I just want to sort of present the options here that we know how much more we can always add more selection criteria for various things. I was just sort of throwing the various ones out there.
Yeah, simple is always good. We can always add on to it later too, if we're looking for stuff or if we find more information.
Mm-hmm. Okay. Was that all your questions, Matt, or did you have? I think there was one more, maybe.
The other one was just, I'm just was trying to, since I'm not bringing any students, I was just trying to figure out how I could best support the students that are going, are participating. And I was just throwing out if, I know we're going, at some point, we're going to do some visual examination. And I was talking with Laura a little bit to get an idea of how this has happened in the past, and was thinking that if there was a student or two that was interested in programming Python or anything Visual Basic, but that wanted to participate in trying to help facilitate that, maybe improve a little bit over whatever the process was in the past. I could help out with that, but I've just throwing that idea. If there's not anybody that's interested in that, that's okay too. But so that was the last item.
It's a good thing to keep in mind for everybody then. Yeah, I think this can not necessarily, the imaging is a little bit difficult in terms of programming, but there are other aspects of this as we're going through that I think certainly programming can help. So everybody should keep that in mind. But of course, we have Matt as a great resource on that one on our team. So keep that in mind. I think that's a very good thing to think about as we're sort of going through the project. So what I'm going to say is, finish off reading the other texts for the next Telecon a week from today. If you have questions along the way, please feel free to email them. We don't necessarily have to wait for, the telecons for me to answer the questions, but certainly, if there's something you don't understand or you're sort of unsure about, certainly feel free to, again, send that question out to the whole group. And yes, yeah, I mean, I think everybody's been doing very well in terms of doing the reply all. I know the etiquette we've been, it's drilled into us is not to do reply all, but for this kind of stuff, definitely do reply all, which of course then makes it a little bit easier, in terms of the subject lines, because it has the Cosmic dIRt in there in the subject line. But if you're generating a new email, again, please, please, please put Cosmic dIRt as the beginning of the subject line, because it makes it so much more difficult for me to find emails because I have many, 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 many different projects all competing for my attention and my time, and I don't get to look at the emails as they come. And so it's much easier just to, okay, this was this project, let me do an email search on that, and it brings in all the emails with that subject line. So it really makes my life a lot easier, and hopefully you will see the advantage of it as you go through it as well. To that, if you want to look for something, you'll have that subject line to search on. Okay. To go into a little bit of logistics now. Sorry, Alyssa, you did not get picked.
That's okay.
But that sort of opens up, which week were we thinking about?
June 18th through, let me pull up my calendar. We talked when we were there about leaving on Monday and doing Monday to Saturday instead of Sunday to Friday, both because of pricing and Father's Day. Is that still something that people are interested in?
So Monday would be a travel day, and then our work days would be Tuesday, Wednesday, Thursday, Friday.
Yeah.
Yes, and then you would leave on Saturday. So the second travel day would be on Saturday the 23rd.
Totally works.
So 23rd. Yeah, that works for me.
That works for me.
That should be good for me also.
Okay.
Okay, well then let's put that in.
Awesome. I actually had a kid with a conflict, and I felt really bad that I wanted to go to space camp more than I wanted Elliot to be able to participate. But now you guys will get to meet the lovely Elliot. So. I'm applying for other things. He's a good kid. He's worth having.
Okay, so we're traveling on 6/18 and on 6/23.
Yes.
Yes.
Okay.
You all need to silence your phones if you're in a text during this.
Okay, so good. We have that settled. Again, with appropriate apologies to Alyssa to not having this opportunity, but hopefully you will get another one soon.
I put in 2 new applications today for other things, so.
Oh, there you go.
There'll be something else. It's not that week.
Okay, so I think I've covered everything that I wanted to cover. So I almost always try and finish off with a roll call, just so that both I put you on the spot, just as well as just to be sure that people aren't just backing off too much in terms of asking questions. So, Tom, any questions or comments?
No, I think I'm good right now.
Okay. Alyssa, how about you? Any questions or comments?
Nope, I'm just kind of acclimating to the information.
Okay. Matt, how about you? Questions or comments?
I think I already talked way too much.
No, that's fine. It switches. Everybody has their moment. So, Nick, how about you? Questions or comments?
I'm just kind of battling a migraine at the moment. I don't really have any major questions right now. Just kind of taking it all in.
Okay. And David, how about you? Questions or comments?
Totally good. I'm looking forward to looking at the spatial distribution of these sources.
Okay, cool. Okay, well then that ends our first meeting. I will send out the video for this. It's a YouTube channel basically that'll have all our videos all together, so everybody can go back and look at all the videos at various different times. So and then you can sort of revisit it or not. It's up to you. And so just remember, we'll have the Telecon again next week, and I'll include the the same information that I did in the earlier email, just so that people have easy access to the various things I want you to read. And then once you're doing that, again, keep an eye out, since you're reading actually the earlier proposals. Keep and sort of have a sense of, based on what we talked about now, what we're trying to do differently than before, and how we're going to formulate that into writing those proposals. Also, remember you were going to have an educational component, and you've talked about doing educational research, so this is about the time also to start thinking about that. And if you're going to be doing educational research, then what questions you're going to be asking, etc., should be probably is worth having in the proposal. Okay, well, thanks everybody for calling, spending the time. So we'll chat them again in a week. Hopefully we'll be chatting even earlier over email. Thanks a lot, everybody. Have a good week.
All right. See you guys.
That was good.
Okay, bye-bye.
Bye,
Have a good night.
guys.
Bye-bye.